So the most important tool, the most recent trending tool in any interviews, you can face the interview questions on this, the main tool, because in most of the interviews, maybe they directly start asking the questions from Kubernetes, or some interviews, maybe they go by tool, like that. Okay, but you can definitely, you won't get any interview without facing the questions on the Kubernetes. So that's why it is very important tool. So recently, most companies are migrating into this Kubernetes architecture, Kubernetes environment. Okay, so till now we have seen the number of ways of deployment. So by using Jenkins, by using Tomcat, by using Ansible, by using Docker. Okay, so we did the deployments. So we, in each and every tool, we found some drawbacks, and those drawbacks can be overcome by the other tool, new tools. Okay, so likewise, we discussed the Docker. Okay, and the last classes. So Docker is very friendly environment. Okay, so it's a container based environment. So we are deploying the all the applications in the container based. Okay, so that it will be accessible at very fast, and we have seen the advantages of this Docker also. That is the Docker also in the last classes. Okay, but so we found only one issue with the Docker. So everything is fine with the Docker, but only one issue. So whenever you are deploying an application in the container, if any chance the container is failed, okay, so it is very difficult to identify why the container is failed. Okay, the reason for failing of Docker container is difficult. So because we don't have any type of system that is provided by the Docker. Okay, so to see the logs. Okay, so in the logs, the information will be there. Complete information will be there. So why the service is failed? So why the container has stopped? Okay, so we don't know the issue. Why? Where is the exact cause? With the help of Docker. So because in the real time, that is very important. Okay, the real time, that is very important. So if any troubleshooting is very important, identifying the root cause is very important in the real time, not only deployment. Okay, so that's why to overcome the drawback, okay, so we are going for the other tool called Kubernetes tool. Okay, so in this tool we have uh, administration privileges will be there. Okay, we have one administrator, that is also called as dashboard. Okay, so dashboard, Kubernetes dashboard, we can call it as Kubernetes dashboard. So this Kubernetes dashboard, here we can see the logs. Okay, there we can see the logs. So I'll show one Kubernetes dashboard for an understanding purpose. So there you can see the complete information of the parts. Kubernetes dashboard. See here. So this is the layout of Kubernetes dashboard. So there you can see the healthy status of the, okay, there you can see the healthy status of the pods as well as containers. Okay, so here you can also see the CPU usage and memory usage. Okay, everything you can see here. Okay, everything you can see. So here you can see the pods, you can see the deployments. Okay, so all these are pods. You can see the status. Okay, so you can see the complete details. You can see the complete details of services which are installed in the Kubernetes cluster. Okay, so that's why, so Kubernetes is very important in nowadays, because it is very handy and easy to work. Okay, so the main introduction of Kubernetes dashboard, and also instead of the dashboard, we can also see the logs. In the command mode also, we can see the logs, so that we can identify the issue. Where is the exact issue, exact problem for filling the container? Why the pod is not running? So we can see everything in the Kubernetes dashboard. So this is called as orchestration. Orchestration means nothing but administration. Okay, orchestration tools. We can also call Kubernetes as orchestration tool. So why we can orchestration means administration. That means we can administrate the complete cluster. Okay, what is going on a cluster we can easily monitor with the help of Kubernetes. So that's why Kubernetes is called as orchestration tool. Okay, it is also container based tool. There in the Kubernetes also we have the containers will be there. Okay. So now we will see the features, the main features of Kubernetes. So why we are moving for the Kubernetes. So in the interviews, so mostly they're asking the question. So why we are opting for Kubernetes? So it's a very, very basic question asking. Okay, so the main, I'll discuss some few points here, why we are going for the Kubernetes. The first one is self-healing. So what is the meaning of self-healing? Self-healing means if any container is failed, if any pod is stopped running, so then automatically one more pod will come to the picture. Okay, if any pod or any container is failed, then automatically so new container will be come into the picture. So that is called as can be applicable by default in the Kubernetes architecture. Okay, that is the main important feature of self-healing. Okay, so next one, secrets and config management. Okay, so in Kubernetes, okay, we can manage the secrets as well as configurations the application level. Okay, for example, if any application requires any secrets, username and password, for example, database is there. So generally, the databases are not bring into the Kubernetes cluster. Okay, the database servers will be out of the Kubernetes cluster. Okay, so but if any configurations which are given to the that is made into the service or application, so those configurations as well as the secrets. Okay, so those are managed in the Kubernetes architecture. So I'll show where the secrets are and configurations are managed in the architecture. Okay, so next point is scaling. Okay, so scaling. So you know the meaning of this auto scaling. So auto scaling means so depending on the requirement. So as per the CPU utilization or any other RAM utilization, the setting you have set. So based on that, the number of parts will be automatically coming to the picture. So that is a main feature of Kubernetes. So it is called scaling. And next one, rollbacks and rollouts. So what is the meaning of rollback and rollouts? Rollback means, okay, for example, you are installed a new version. Okay, an application with a new version is installed, but identified the bugs in the new version. So you need to roll back to the previous version. So that is easily you can do with Kubernetes. That is easily you can do with Kubernetes. Similarly, rollouts. Rollouts means upgradations. You can easily upgrade to the new version. Okay, that is called rollout. Okay, if rollback means so downgrading the version. Okay, rollouts means upgrading the version. So that's the main one more important tool. The next one, load balancing. Okay, load balancing. So we can run. Okay, we can run the multiple services. Okay, by using load balancer. Okay, for example, you have a multiple context paths. So all the multiple context paths you can given in a single file. So you can easily manage by using the load balancer case. Okay, so these are some main important points of using of Kubernetes. Okay, so next very very important question. So without this question, there will be no interview. Okay, so without this question, there will be no interview. First, the very basic question they're asking: explain the architecture of Kubernetes. Explain the architecture of Kubernetes. So if you see the Kubernetes architecture here, so Kubernetes is also called as K8s. Why it is called as K8s means if you count the letters between the K to S, so those will be 8. Okay, if you count the letters from K to S, the middle, so you'll find the number of letters as 8. That's why it is called as K8S. Okay, so K8S architecture. So you can see number of diagrams here. So take any one, all are giving the same type of information. So here the main thing, okay. So first you need to understand the basic terms. So what is when before going to the Kubernetes architecture, you need to understand the basic terms. So that is first one is node. So what is the meaning of node? Node is nothing but a machine. That means or instance. You are creating one instance right and AWS. So that instance is called as node. Okay. So mainly architecture of Kubernetes has two nodes. One is master node, another one is worker node. Okay. So main architecture of Kubernetes having two nodes. One is master node, second one worker node. So this is the main master node. Okay. And these are the worker nodes. Okay. These are the worker nodes. So generally, so depending on the environment, so by default, we have one master. Okay. So you can have n number of nodes. So depending on the environments. Okay. You can, depending on the environment and application, you can have n number of nodes. So for example, if you take one master and three nodes, okay. So this master will not do, we are not doing any deployment in the master. Okay, we are not doing any deployments in the master. So master is the controlling the nodes. Master is also a instance. Total how many instance? So master node, that is one instance. Here three worker nodes. Okay, so total 4 instances will be there. That means 4 machines are running. 4 machines are running. Out of 4 machines, one is the master, which is controlling the remaining 3 machines. Okay, the one is controlling the remaining 3 machines. So this entire group, that is one master and 3 nodes, the combination is called as a cluster. Okay, the combination of master and worker node is called as cluster, or also called as Kubernetes cluster. Okay, what is meaning of cluster? Cluster is nothing but it is a group of machines. Cluster is nothing, it is called as group of machines in which one master node will be there, and so depending on the application, some number of worker nodes will be there. So minimum 2 worker nodes will be there. If you create by using COPS, okay, so you will get at least minimum 1 and 2 worker nodes you will get. Okay, so this is the main terms you need to understand. What is meant by node and what is meant by master node, what are 3 worker nodes. So here, if you observe here, so this is a main master node, and we have some here 2 worker nodes will be there. So this is a node 1, this is a node 2. Okay, and if you see any organization, so actually here printing mistake, here, this is a node 2. So the content of master and the content of nodes is different. Okay, so first we will go to the master. So what are the main uh, points in the master? That means what are the main parameters in the master? So if you see here, main blocks. So here etcd, controller manager, scheduler, kube API server. So these are the main 4 parts in the master server. Okay, these are the main 4 parts in the master server. Okay, coming to the in the worker node. Worker node we have 2. One is kubelet, another one is kube proxy. So here that is not given here. So we will see one more image. You can get clear idea. So this is the main master node. You see here, this is the main master node. Okay, so these are the 2 worker nodes here. You can see 2 worker nodes here. So the master node, it is having main parts, API server, and controller manager and scheduler. Okay, and it is also having the etcd. So major 4 parts will be there in the master. So what is the master node? It is having master node is having etcd and API server, and next uh, scheduler, and controller manager. Scheduler and controller manager. Okay, so next worker node. So what is the main parts of worker node? Majorly in the worker node, there are 2 parts. One is kubelet, another one is kubeproxy. Okay, so these are the main parts of Kubernetes cluster. So in the interview, definitely you'll ask the question, they'll ask the questions. You need to be in a position to answer each and every in detail. Okay, so now what is etcd having? Okay, so etcd, it is responsible, it is having the complete cluster information. Okay, complete cluster information that is stored in the etcd. Okay, so that means whatever the how many number of pods, how many number of containers. Okay, so each and every detail. Okay, what are the configurations, what are the networks, everything that will maintain by the information that is provided in the etcd block. Okay, next, what is API server? So API server, it is nothing but it is the main gateway. Okay, it is the main gateway. So that means it is the entry point. So it is the entry point where if the customer hitting the any URL, first it will hit the API server. First it will come to the API server. From this only it will distribute to the internal cluster. That means it is acting as a medium. Okay, so from this gateway only any request that is passed to the services. So that is a major importance of API server. This is a main entry point, and uh, it is a main gateway which establishes the communication between the end user and the cluster. Between user and cluster. Next, scheduler. So it is very, very important, scheduler. So the main option, the main use of this scheduler, the name itself indicating it is scheduling the pods. Okay, scheduling the pods. So what is the meaning of pod? So pod is nothing but a group of containers. Okay, we are calling as a pod. Pod means it is a group of containers. You know that in the container we are deploying the applications, right? So a single pod, in a single pod we can deploy n number of applications. That is depending on the memory. So depending on the memory in a single pod, we can deploy n number of applications. But in the real time, generally in one pod, only one application that is deployed. Why? Why means if the pod is went wrong, so what happened? The applications which are in the pod will everything will be gone. So that's why each and every application that is placed under a single pod. Okay, each and every application that is generally placed under a single pod. Okay, so that is the meaning of pod. So pod is nothing but group of containers. Okay, so here scheduler is nothing but it is responsible for scheduling the pods. Okay, the main important is starting the pods or stopping the pods. Okay, the activities that is it can do. That is the main importance of this the scheduler. For example, as I mentioned previously, right? So if auto scaling is required, that means the number of pods should be increased. The service in the service in a pod is not able to reach the customer. Then what happened? Because of RAM utilization, it is not able to reach the customer. Then what happened? Automatically, one more pod should come to the picture. So that kind of activities can be done by the scheduler. Because see here, it is in the master node. So master node, okay, these are the components which are there in the master node. So these components will control the pods in the worker node. These components will control the pods in the worker node. That is the main that is why it is called as master node. In the master, we are not doing any kind of deployments. Okay, because it is the main key role. It is playing a very key role because it is the main person. Okay, if the master is lost, then everything will be lost. That's why in the master, so we are not deploying any kind of we cannot do any kind of deployments. Okay, so next, controller manager. So the name itself indicating it is controlling. The main function is it is controlling. So we have a different types of controlling it can do. So it is controlling the nodes. Nodes means machines. So it is always checking the CPU utilization and RAM utilization. Okay, so everything it is controlling. So and if anything is happen, immediately it will pass the information to the this API server, so that it will make the corresponding changes. And also, if anything, if CPU utilization is more, then what happened? It immediately intimates the scheduler. So to install to create one more pod. Okay, if the CPU utilization more, this controller will inform to the scheduler to create one more pod. So like that, so it is main node controller, and you can also do the replication controller as I mentioned right now. Okay, replication controller means it is giving the replicas. Okay, the same pods it will be creating as per the requirement. Okay, so next one, endpoint controller. Endpoints means that is URL, the accessing URLs. Okay, so it will also control the endpoint controllers also. So like that, we can discuss about this master node components. The main components are etcd, API server, scheduler, and controller manager. Okay, so next one, in the worker node, the main two components are kubelet and kubeproxy. Okay, so these two components are running on each and every worker node. If you see the architecture, so the kubeproxy and kubelet both will be there. So in each and every pod, these will be running. So kubeproxy is there in the pod, and kubelet is also there in the same pod. For all the worker nodes, in all the pods, these two components are running. Okay, so what is the importance of the kubelet? So kubelet is nothing but it is always communicating with the API server. In the kubelet only, we are deploying the pods. Okay, so see here the kubelet. So it is establishing the communication between the container and the API server. See the arrow marks here. So kubelet, it is nothing but it is establishing the communication between the API server and to the containers. Pods, in the pods, we have the containers will be there. Therefore, it is major whenever the customer hit the request. So then what happened from the API server? The request will be go to the kubelet, and from the kubelet, so it is going to the service, and from this service again the request will be given to the API server, and from this it will come to the user. So likewise, it is playing a main role. It is establishing a communication between the API server and the this container. Okay, so kubelet it establish communication between API server and container. Okay, so next kubeproxy. Okay, and also it is depending on that, it will start the container, stop the container like that. Next, kubeproxy. So kubeproxy means nothing but it is a network proxy. Okay, it is nothing but network proxy. So this also runs on each and every pod, okay, of each and every worker node. And what it is means, it is doing the so see here the kubeproxy. It is nothing but it is establish the communication between the pod. Okay, it is establishing. It is not going with a container. Okay, it is just establishing the communication between the two pods. Okay, it is establishing the communication between the two pods. So it is always connected to the pods inside the node. Okay, it is always connected to the number of pods which is inside the worker node. So it established the communication between the pods. Okay, so it is a network proxy. So what it can do, it establish communication between the pods. Okay. So Kubernetes established a communication between the container and API server. Kubeproxy established a communication between the pods. So that is the main use of the Kubeproxy. So likewise, we can answer in the interviews whenever they are asking the architecture of Kubernetes. Definitely, you will get this question in the interviews, no doubt. 100% in every interview. Okay, you can face this question. Okay, so that is about this architecture topic. And coming to our topics, the main topics. So I can't discuss about more theory in the Kubernetes section. So if you want, you can read from the internet for a lot of stuff is there. But my objective is to always do the demo only. Okay, that's why. So whatever the important that is up to for interview, that point I explained right now. So what is the main importance of what is the main uses of Kubernetes, and what is the main architecture of Kubernetes? So what is the difference between why you are going for Kubernetes instead of Docker? So such questions generally you are facing in the interviews. So those questions I have answered here. Okay, right. So now, any doubts up to this part? No.
Nothing, sir. Very clear, sir.
Okay. Now I'm telling you about how to create the cluster. I already told you. Okay, the cluster is nothing but a combination of nodes, right? Okay, one master and a number of worker nodes. So how to create the cluster? So that is the main question. So we have some options to create. Okay, the cloud providers, depending on the cloud providers, so we have some options. For example, if you're using AWS, so then AWS is providing one type of cluster creation that is called as EKS. EKS means Elastic Kubernetes System. Okay, AWS, Amazon AWS, it is providing the Kubernetes service that is called as Elastic Kubernetes System. Similarly, Azure, that is Microsoft, that is providing service name called AKS, Azure Kubernetes Systems or Services. Okay, Elastic Kubernetes Services, Azure Kubernetes Services. Okay, and we have also instead of, but these are not free. Okay, these two services are not free. If you go to the Amazon website and if you go to the AKS, okay, that part I will show tomorrow how to create AWS cluster tomorrow class. Okay, that means it is not free. Remember, the creation of cluster is not free. I'm not creating any cluster here. Okay, with EKS or AKS or any other. We have also some third-party tool. Okay, we can also use third-party tool, so called COPS. Okay, third-party tool is called as COPS. So what is the meaning of COPS? COPS means Kubernetes operations. Kubernetes operations, but it is free. Okay, this is free. Okay, only the third-party tool that is COPS is free. But what is the issue with the third-party tool means there is no guarantee. Guarantee means there is no service. Okay, for example, if there is an issue in the EKS, so Amazon will take care. Okay, if there is an issue in the AKS, okay, Microsoft will take care. But it is a third-party cluster, third-party tool. Okay, so nobody can give the service for this. Okay, nobody can provide the service for this. So that's why mostly in real time they're preferring the COPS because of its free service. But if you install the COPS properly, mostly no issues will be there with the COPS. But these two are chargeable services, not free services. Okay. So apart from this, some in our local to practice for the student purpose. So we have a single node. Okay. So single node single node tools will be there. Single nodes Kubernetes clusters will be there. Okay, single node Kubernetes cluster will be there. So those single node Kubernetes clusters are nothing but, for example, if it is a Windows machine, okay, it is nothing but Docker desktop. That means the Docker desktop itself, it is working, it can be used for Kubernetes. For example, if it is a Linux machine or Ubuntu machine, okay, there we are working with the Minikube. Okay, we are working with the Minikube. So these two are single node clusters. That means single node means we have only one node is there. Okay, only one node. That is the master, that is the worker node. So in that node only we are doing the deployments. In that node only we are doing the deployments, right? So we are working with only these two, okay, Docker desktop as well as Minikube. So we are working only with these two tools. Okay, so today I'm going to explain Docker desktop, that is Kubernetes in the Docker desktop, and in the tomorrow session I'll explain the Minikube. But remember, the working is same. The working nature, working with Docker desktop and working with Minikube is both same. Okay. So, and moreover, very, very important point, mostly in the Kubernetes, we are working with only one command that is called kubectl. Okay. In the entire Kubernetes, we are working with the single command to kubectl. With the kubectl only, we are working with, we are working. Okay, so that's why we see the architecture. So there you can see at the starting, you have kubectl is there. So see the kubectl. So this is the main point. Whenever if you want to enter into the cluster, so with the command kubectl only, you are logging into the cluster. Okay, so again we have the load balancers also there. So I will explain this part. Okay, so end users who give the getting the access by using the load balancer concept. Okay, so anyway, so now to this part. Understood, right? So how we are creating the cluster? So if it is Amazon, so we have AKS, and Azure we have AKS, and third party tool is called COPS. Okay, so and also apart from this, we have a single node cluster also will be there. If you are using a Windows, it is a Docker desktop, and if it is a Linux machine, so it is Minikube. The tool we are using is Minikube. But remember, for Minikube, we require two CPUs. Two CPUs means you need to take at least T2 medium. T2 dot medium. So this is chargeable, not free. Okay. So like that's why if you are installing the Docker in the Windows, you can also practice with the Kubernetes for free of cost. But installation of Docker in the AWS is free. That is the instance is free. Okay, that is you can work with the one CPU machine, free-tier machine. You can work with the Docker, but for Kubernetes for minimum Minikube, so two CPUs are compulsory. Okay, so that part I'll explain tomorrow. Right. Now, before that, and just to show some commands. So, what are the commands we are going to work in the Kubernetes? The first basic command is kubectl version. So, if you see, all the commands are working with kubectl only. Okay. So, kubectl version, it is showing the version of the Kubernetes. So, kubectl cluster info, it is showing the complete cluster information, shows the mass Kubernetes cluster is running and kube DNS is running. Okay. So next kubectl get node. Get node means how many number of nodes are there. Okay. Currently in the Docker desktop we have only one node, right? Windows machine. So it is only one node, one Windows machine only. That's why it is showing only one node. But in the real time, if you see, minimum 3 to 4 nodes will be there. So depending on the applications. Okay. So next, so what is a node? So node is having the pods, and pod is called as group of containers. Okay. So if you want to launch a container, we need to create a pod. Okay. So if you want to launch a container, first you need to create the pod. So what is meant by pod? So pod is nothing but a group of containers. In each and every container, we have one service. So we can have multiple containers in single pod, but in the real time, only one container for one pod is taken because of security, not security, for safety. Okay. So next, coming to the kubectl, the usage of tool, that is command. So generally, the kind means there are three types of uh, terms you can see here. One is pod, second one is deployment, third one is service. So pod means that you have shown, right? That you have seen. Pod means that the group of containers is called pod. That means with this pod, you are creating the containers. With the help of the pod, you are creating the containers. So now deployment, the name itself is indicating deployment. So with this deployment, you are deploying the application in the pod. Okay, that is in the containers. You are deploying the services in the container. Okay, so there you can do update and rollback without zero downtime. That is the main feature of Kubernetes. You can do update and rollback without zero downtime. Okay, that means there is no downtime. Okay, if you access the application, so within fraction of seconds you can do update, within fraction of second you can roll back without down the service. Okay, so if you use deployment object, so pod will automatically create it. So that is the main advantage. So there is no need to create pod separately. Okay, if you do the deployment, the pod automatically create. Okay, if you do the deployment, pod will be automatically created. Next, service. So service means the exposing of deployment is called, okay, service. Exposing of service, that means on which port, okay, on which port you want to access this application, that is called as service. On which port you want to access the application, that is called as service. Exposing of deployment to access the application is called service. So generally, there are 4 types of services in the Kubernetes. If you learn these 4, that is enough. Okay, Kubernetes is over. Okay, if you learn these 4 services, Kubernetes is over. Okay, in interviews also, they are mostly asking these questions. So what are the different types of services? So the first service is cluster IP. Second one is node port. Third one is load balancer. Fourth one is ingress. So first one, cluster IP. So if you are using the cluster IP as a service, then what happened? You are the application that is not exposed to the outside of the world. Okay, the application that is accessed only within the cluster. Okay, the application that is accessed within the cluster. The application should not be exposed to the outside of the world. That means you cannot access the application with internet. Okay, you cannot access the application with the internet, only with the in local. Okay, that means if you hit any application, for example, let us take example.com. One application is there. Let us take one example.com is one application is there. So if you bring this application within the cluster, if you type example.com from your internet, so this application is not able to access. Okay, this application is not able to access. If you want to access this application, you must be in the cluster. You must be in the cluster. Then only you are able to access this application. So that's why database servers, so we can call it DB servers. All the DB servers are generally placed in the cluster IP. Okay, so that means no other persons are able to access the DBs. So DBs should not be exposed outside, right? Okay, so it is having the sensitive information. That's why DB should not be exposed outside. So that's why DB server should be placed within the cluster only. But generally in the real time, so DB is also not placed in the Kubernetes cluster, because if the cluster is failed, then entire information also will be failed. So that's why. So we have separate process will be there for bringing the DB servers into the Kubernetes cluster. But in the real time, that is not doing. Okay, so we are placing the DB servers outside of the Kubernetes cluster, but we are enabling the communication between the DB servers and the cluster. But however, if you talk about the application point of view or any service point of view, so if you choose the service as cluster IP, so then the application that is accessed only within the cluster. Only inside the cluster only you are able to access the application. Outside of the cluster, it is not possible to access the application. That is the cluster IP. Next, node port. So if you choose the service as node port, so what happened? So node means machine, right? Okay, that machine have some port. So with that port only, that application will be accessed. Okay, with that, for example, I'm using my Windows machine. So for Windows machine, so I have the IP as localhost. Okay, I can provide the port for this. Multiple ports I can provide, and I can access the application by using the local host. Okay, by using the local host only, I'm able to access the application. So if you take any other application, okay, so if you place any IP in place of local host, so this is not work. That means where the service is installed, where the cluster is installed, well, that cluster has the node, right? So in that particular node only, so this application is accessed. Only that particular IP can able to access the application. If it is a Windows machine, you have the local host. For example, if you go for any AWS, so then for Linux machine, you have the IP is there, right? To move into the any cluster, you have the IP is there. So with that IP only, you are able to access the cluster application. Either that is called as node. So with the node IP or with the node IP only, you are able to access the application. That is node port. Understand the difference between cluster IP and node port? The difference. So here within the cluster only, you are able to access the application. So this is with the help of only node port, you can get the access. And next one, load balancer. Before going to this, I'm telling you about ingress. So ingress is also load balancer. Ingress is also load balancer. So what is the meaning of load balancer? You know the meaning of load balancer, right? Load balancer means, for example, if any service, okay, so say example.com. So if the service has multiple sub-services, we can call them microservices. We can call them as microservices. Example.com under this. Okay, let us take a simple example. So let us take Flipkart is there. So in the Flipkart, so if you go to the mobile section, so /mobiles. So this is one service. Okay, similarly in the Flipkart, you have TV section is there, for example. So TVs. So all these are microservices. For mobiles, we have a separate service, and TVs are separate services there. Okay, so if you want to access all these, okay, so just bring all the microservices under the ingress load balancer. Okay, just bring all the microservices inside the ingress load balancer. Then you can access these applications. Okay, so no need to deploy number of times. If you deploy only one time, then just within this slash, you can change the context path, then you are able to access the application. That is ingress load balancer. So next one, load balancer. So this is the external load balancer. Okay, this is the internal load balancer we can call. This is the external load balancer. That means same functionality. Whatever the ingress it can do, the load balancer also can do the same functionality. But the difference is it is performing internally. That means for checking purpose. Okay, for checking purpose, you can use the ingress load balancer. If it is working fine, then so you can give the DNS mapping, okay, to the IP, and then you can give the load balance. Okay, this is for external purpose and this is for internal purpose. So these two are for multiple services. These two are used for multiple services, microservices. Okay, so these two are for single services. So cluster IP and node port. Understood? Any difference, any doubts here, the types of services, because this is very, very important.
So can you please explain one more time?
Okay, so generally we have 4 types of services in the Kubernetes. That is cluster IP, node port, load balancer, and ingress. So in the cluster IP, So if you are giving the cluster IP as a service, the application can be accessed only within the cluster. So outside of the cluster, the application cannot be accessed. Okay, when you go to the examples, you can clearly understand why we are giving cluster IP, what is a node port. So only within the cluster only the application can be accessed. And coming to the node port, so with the machine node is nothing but machine, right? So with that node IP only, you are able to access the application. The node has some IP. If it is a Windows machine, you have the local host. If it is the AWS machine, you have the IP. So with that IP followed by the port, you can able to access the application. That is the use of the node port. And ingress as well as load balancer. So these two are nothing but load balancers only. Load balancer means you already practiced in the AWS, right? Load balancer section. There you are giving the number of services, number of multiple services you are given. Okay. So for that, so if you want to access the multiple servers inside the cluster, then you can use ingress load balancer. If you want to access the multiple services, microservices. Okay, so I'll tell you how to give ingress load balancer. And similarly, this is for external load balancer. We can call this load balancer as external load balancer. So this is called as internal load balancer. Okay, within the cluster only, you are able to access the applications. But if you choose the load balancer, so external access will be provided. External access will be provided. That means only the people who are in the cluster can able to access if we choose ingress. If we choose ingress, only within the cluster, the people can access. Okay. If you choose external load balancer, then outside of the cluster, anybody can access the application. Anybody can access the application. Because the external application should have the domain name, right? Okay, external application should have domain name. So that's why DNS, so domain naming system. So therefore, external load balancer can have the domain names. Therefore, it is available to the customers. Whereas if you choose the ingress load balancer, so it is, you can give the DNS, no problem. Okay, but that is the services which are accessible only inside the cluster. Only inside the cluster, the outside of the world, so that cannot access these applications. Only the people who are connected in the cluster, they only can access this application. So that is the ingress load balance. Clear?
Yes, sir.
Right. So the remaining commands. So kubectl create. So it is mainly used to create the pod or service or deployment. Okay. So I'll show how to use these commands. So next, kubectl get pods, use it to see the pods. Use kubectl get deployments, use it to list out the deployments. Kubectl get services, it is used to show the services. Okay. So kubectl describe. So describe means it is used to the complete information of the pod. Okay, describing the pod. So what is the how many number of containers, what is the status, everything you can show here by using the describe pod. So similarly, describe deployment. So describe service. So the complete information will be here, but you can get pods means it is showing how many number of pods which are running in the cluster, that is showing. How many number of deployments it is running, it is showing. How many number of services it is showing. If you want to describe any specific pod, so you need to give like this: kubectl describe a pod followed by the pod name. Okay, similarly, describe deployment followed by deployment name. Kubectl describe service name. So if you want to delete the pod, so kubectl delete pods, pod name. So delete deployment, so deployment name. So delete service name. Okay, if you want to delete any file, so kubectl delete -f. Okay, any name, either pod or deployment or service, any name, the name of the service. Okay, so likewise, we can work with the kubectl commands. Okay, so I'll start Kubernetes now in the Windows machine. So for this, just open the Docker. In the Docker, so go to the settings, the Kubernetes. So just select this one, enable Kubernetes. So that's it. So Kubernetes will be enabled. Okay. So whenever you enable the Kubernetes, so automatically, okay. So this is very, very important in the real time. Automatically, config file will be created. Where the config file is created? In the user's home. So see with the name .cube. Okay, with the name of .cube, one config file will be created. So this is a very, very important file. Without this file, you cannot communicate with the cluster. Okay, this is a very, very important file, config file. So this config file is created whenever you create the cluster. Okay, if you create the cluster using COPS or EKS or by using Docker desktop or Minikube, whatever the channel you are creating the Kubernetes, so this config file will be created automatically. Okay, this config file will contain the information, the cluster information. So it will give the complete cluster information. So it is ABA version V1. So cluster is the certificate of the cluster. Okay. So this is a server. So Docker Kubernetes Docker. So this is a server name. So what is the node name? It is a Docker desktop. Okay. So user. So the config file. So client certificate. So client key data. So you should not do any changes in the configuration file. Remember, this is very, very important. If you do any changes, you are not able to connect with the cluster. You are not able to connect with the cluster if you do any changes in the config file. Okay, that is very, very important. Right? Next. So come to this one, just close this. So we are working with the command line only here also. So first command is kubectl. This is a command. If you click on enter, so you can see the list of commands. How to use kubectl, Kubernetes. So you can see the basic commands to create, expose, run, set. Okay, so basic commands explains. You can read all the commands. Okay, you can read all the commands. So only these commands are there. We can work in the real time with only few commands. Okay, not all the commands. So depending on the application. So first command kubectl version. If you see the kubectl version, so it is showing the client version as well as server version. So these two should be there. Okay, client and server should be there. Then only you can work with the Kubernetes. Similarly for Docker also. Okay, for Docker also, if you see the client as well as server, both should be there. Then only you can work with the Docker also. Otherwise, you cannot work with the Docker. Okay. So now kubectl version. After that, kubectl cluster info. Next command is cluster info. So it is showing the what is a Kubernetes control plane is running. Okay, and kubedns that is also running. So from this only the information it is taken. Okay, now next one kubectl get nodes. See, currently it is having only one node. That's why I told you previously. It's a single node machine. It is a single node machine. So it is the name of the node is Docker desktop. Okay, right. So this is about kubectl get nodes. Next one, kubectl get pods. Okay, currently one pod is running. Okay, so just delete this pod. Kubectl. So see the importance of Kubernetes here. I'm deleting the pod. Kubectl delete pod name followed by the pod name. Pod name means you need to give the entire name. Okay, so click on enter. So pod is deleted, but don't think that the pod is completely deleted. If you check the kubectl get pods, again one more pod is coming to the picture. If you see the kubectl get pods, see one more pod is running. If you see the name of the pod, hello one up to hello one, the name is same, but after that the name is different. Okay, so see here the end name is CZM. Here SH1. The name of the pod is different. Okay, if you delete the pod, still one more pod is to come into the picture. That's why the application is running continuously without a zero downtime. Even though one pod is down, okay, in the pod is containing containers, right? In the containers, we have the applications. If one pod is go down because of any reason, automatically one more pod will come into the picture. So that is the main advantage of Kubernetes. So without zero downtime, we can provide the service. So how to delete this pod? So for example, we can see one more thing. So kubectl get deployments. So here one deployment, one service is deployed. Hello one is a service that is deployed. Okay. So whenever you do the deployments, automatically pod also will be generated. Okay. So next one, kubectl get service. So you need to work with these three commands in real time. Kubectl service. So I have two services. One is Kubernetes service. This is a default service. You should not delete this service. Okay, Kubernetes service. It is working on the cluster IP. So within the cluster only, you are working with the this service. Okay. So next, Hello One is application that is working on the node port. Okay. So this is running on the node port with this port 31521 on this port. This application is available. Hello One application is available. For example, if I want to delete this deployment, if you want to delete the pod, so it is not possible to delete the pod. If you kubectl delete pod, again one more pod will come into the picture. Then how to delete the pod? I don't want to see this pod. Then you need to do the deployment. You need to delete the deployment. If you delete the deployment, pod also will be deleted. If you delete the deployment, pod also will be deleted. If you create the deployment, pod also will be created. Okay. If you create the pod deployment, pod will be created. If you delete the deployment, pod also will be deleted. Okay. So service is a separate one. You need to delete it separately. Okay. If you want to see entire list, all the information, that means pods, deployments, services, everything you want to see. So then the command is kubectl get all. Kubectl get all. So this will show the complete information. It is giving the pods, it is showing the service, it is showing the deployments, and it is showing the replica set. So see here, in the auto scaling, you are giving the points, right? You have given the information. So desired, current, ready. There you are giving the minimum, maximum, desired. So here also same thing. So if you desired is 1, current is 1, ready is 1. If you set the replica set to 2, then 2 pods are available here at any time. So now I want to delete the pods, I will delete the services and deployments. Further, the command is kubectl delete. So kubectl delete. So I can just copy this line, paste here. Space. I can delete at a time all. Space. So these two are sufficient. If you delete the service, if you delete the deployment, remaining everything will be deleted. No need to give the pod, no need to give the replica set. So these two are the major things, service and deployment. These two are the major things. So click on enter. So service hello one deleted, deployment hello one deleted. Now if you see, check again, kubectl get all. So nothing is there. Only the Kubernetes service is running. Only Kubernetes service is running. Understood? So these are the basic commands we are working with. Now, let us deploy one simple application first, Hello World application. So that Hello World application you can see in the internet also. Okay, Kubernetes, kubectl, Hello World, Hello World, Kubernetes. So you can see the example here. So create a deployment. So with the help of this command, kubectl create deployment. Okay. So here the name of the deployment. Here you can give any name. So So the name of the deployment is hello node. And here the image is already available. This is hello world is the image that is already available in this repo. That's why we are calling the image from this. Okay, this is only for practice purpose. Hello world, anybody can use. This is a basic one. Okay, just type copy and paste here. So click on enter. So it is showing deployment.apps. Hello node is created. Now, so if you see the command kubectl get deployments, so then see hello node is there. So one by one. So the meaning of one by one is, so one deployment you made and one is ready. Up to date is one, available is one. Okay, out of one deployment is ready. So the same thing. So if you want to see the pods, so kubectl get pods. So this is a pod name. So this pod name is randomly assigned. It is not given by ourselves. It is randomly assigned. So, but this name is given as per the deployment name. Okay, so you at any time you need to see this status is running, and restarts should be 0. The pod should not be restarted in the real time. If the pod is restarted, it means there is some issue with the pod. You need to check the logs. Where is the issue will be there? Okay, where is the issue is there? You need to check the logs. Okay. So next, if you want to check the logs, for example, if you want to check the logs, the command is kubectl logs -f followed by this pod name. Click on the enter. So this is a command used to check the logs. Check the logs. Okay. Okay, it is taking some time. I will tell you this about later. So next, now, next I want deployment is completed. Next, I want to expose the service. So see here, I want to how I can expose the service. Yes, so kubectl expose deployment. Exposing of deployment is called service, right? Exposing of deployment is called service. So therefore, kubectl expose deployment, hello node, and the type. So what is the type of service? Here you can give type of service is cluster IP, node port, or ingress or load balancer. Anything you can give. Hyphen port, on which port you want to run the application. So this is you can pass here. Okay. Okay. But in place of load balancer, I'm giving the node port because to get the load balancer, I need the domain name, but I don't have any domain name. Therefore, I want to access the Hello World application with my node, with my Windows machine. So on the port 8080. So click on enter. So now service is exposed. Service is created. So exposing of deployment is called service. So now if you want to see all whatever you created, so kubectl get all. So see here, you have created the hello node and you have created the pod. So pod is automatically created when you do the deployment. Okay, so service is created. So this service is here. The type is node port. You have given the type as node port. Therefore, here the type is node port. So this is the cluster IP, and there is no external IP here. Okay, because you are using the node port within the node only. So next ports. So this is the main container port, and this is a target port. Okay, so 32550 is the target port. So if you want to access the application, so in local, okay, in the command mode, if you want to access the application, you can use the curl command. So curl command you can use. So curl localhost followed by the IP. So 32550. Okay, followed by, so I think what is the hello node. So localhost it is listening. So let us check what is the context path we need to see. Instead of this, we will see one more.
Sir, if it is like if you mention load balancer, then do we need to mention port or what? So, like earlier we have discussed like the users will be accessing the containers like pods by using load balancer. So in that case,
Sorry.
then so earlier we have seen, I mean, while looking at the containers or the node 1, node 2, the architecture of Kubernetes, the users can access the nodes or what is the pods in nodes by using load balancers only. That's what we have seen also. In that case, do we need to mention the ports or not? If load balancers, then how to access the application?
Yeah, I'll show that, sir. I'll show that later. First, I'll come with the service by service. First, I'm explaining about the node port. So after that, I'll explain the cluster IP and load balancer later.
Oh, okay, sir.
So here I have given the examples. So let us do this. So I'm deleting this kubectl get all. Yes, because we need to know the context path. So kubectl delete. So now I want to expose this one. So this is a deployment, the same thing. kubectl delete deployment hello one. So hello one is the service, the deployment name. So this image I'm taken from here. So deployment is created. Next service is created. So here I'm taking the node type as node port and service name is hello one. Here the deployment name is hello one. Now if you see the kubectl get all, so now you can see the service name is node port and it is accessing under 3185859. If you see local host 31859, okay, followed by hello one. See here, you can able to see the application now. This is locally you can check without accessing the application on the web browser. If it is working in the local, it should also work in the internet, that is in the Chrome. So just copy this, paste here. See, you can able to see the application. So these are basic node port. Okay, so if you want to do one more deployment, because I have updated the version with hello.2. Okay, for this.
Sir, will this image, I mean, are these images given to us, will they be given to us or do we need to create them?
No, it is already existing one. So these all images are existing in the gcr.io in the Google samples.
No, these are hello and hello to their sample applications too, sir. So that we are getting from Kubernetes website, somewhere it may be.
Okay.
But in the real time, like, will these, I mean, are these images available?
Okay.
Like, will we be getting
in the real time, I already told you the images are already given to you by all. You need to create the images. Sometimes, depending on environment, sir. Okay, some people are directly giving the images, or some people just giving the code. If the people are giving the code, you need to build the images. Okay, If some people are directly giving the images, you can work with the images. Okay, generally the images are placed in the repositories, right? If it is an access, okay, or Docker. So in that repositories, you are storing the images. From that repositories, you are calling. Okay, from that repositories, you are calling the images. I will tell you how you are calling the images later sessions. But is a basic
No
example.
image is given, then we need to, by using SonarQube or whatever it may be, we need to create the images. That's it. Like by using snapshot option, whatever it may be, we need to create the image.
SonarQube,
Not
you are used to checking the test reports there.
reports only.
Testing of application. Testing of application with SonarQube. Nexus is the
Nexus.
artifactory where you are
To
storing
store
the
the
images.
images or all the versions of images. Okay.
All the versions also you can store there. From that, so here you can call that repository. So there you can view the information of that repository. Okay, I'll tell you how you are working with the repositories also in the coming in this tutorial. Okay, so now I'm updating this with a new version. So hello to created, and after that I'm exposing the same service. Okay, same node port. Now if you want to see all kubectl get all. So now here service hello2 also will be there. So this hello2 is available on the port 30447. Now if you access the service localhost 30447, see here, there you can see hello world. Likewise you can work with the node port. So these are the basic examples. I'll tell you our examples how we are creating in our local. So in the last class already, while preparing the Docker, you know that you are pushing the images to the repo, right? Okay, you are creating the images. For example, Docker images. You check the Docker images. So currently I have these images are there in my local. So if you create two more images, then you can easily understand how to work with this. So here I have created one image, 3 apps. In this, I have the three applications will be there. In this, I have 3 applications are there. Okay, let me show the applications also.
Sorry,
Yeah.
నేను నిన్న మన క్లాస్ వెళ్ళలేదు, దానివల్ల నాకు ఇమేజ్ క్రియేషన్ ఆల్రెడీ ఇక్కడ ఈ క్లాస్ ప్రీడిఫైన్ యూస్ చేస్తున్నారు కదా, క్రియేట్ చేయాలని చెప్పేసి నాకు డౌట్ వచ్చింది. సారీ సార్.
Okay. So in the last class already we have created the applications. Okay, in the 3 apps I have created 3 applications, and those 3 applications are available under the image hi 3 images in the version 1.0. Okay, let us see first before going to the images. So how to create the deployment? So generally here in the previous example, the image you are taken here, but in the real time, generally you are working with the YAML files. Okay, you need to write the Kubernetes files. That means for creation of pod, for pod creation, you need to write one YAML file. For creation of deployment, okay, you need to write one YAML file. And for creation of service, you need to write one YAML file. YAML or YML, anything is fine, no problem. Both are working. Okay, so for each and every, you need to write one YAML file. So even for pod, it is not required, but for deployment and service, because if you do the deployment, pod also will be automatically created. Okay, so how to write the Kubernetes values files? We can call them as values files. We can call them as values.yaml files. Okay, there you can see the deployment, you can see the service, and you can see the pods. So I'll show a sample YAML file here. So see here, this is the sample deployment file, and this is the sample service file. I'll explain this file now. So now any Kubernetes YAML file that is for deployment, okay, it is starting with API version. So what is the API version? API means application peripheral interface. Okay, so that version is given as apps/v1. And next kind is deployment. So what is the type of the kind? What is you are doing? Are you doing pod or creating the pod or creating deployment, creating a service? So currently I'm creating a deployment. Therefore, here the kind is deployment. And the metadata. Metadata means you need to give the information of the deployment. So here the name of the deployment is, you can give any name here. Okay, you can give any name here. I have given 3 apps hyphen deployment. I have given 3 apps hyphen deployment, DEP. You can give any name here. After that, you need to give the specs. Okay, spec you need to pass. So here the specs. So here the replicas you should pass. That means how many number of deployments you want to create, how many number of pods you want to run. So here you can change the replicas. If you keep one, only one pod is running. If you keep two pods are running. So depending on the application, you can change the replicas. Okay, depending on the applications, you can change the replicas. Okay, so next selectors and match labels. So these are the default one. So next application name. Okay, you should give the application name 3 apps. Okay, you can give any name, but the name should match. So here in the match labels and in the labels, so the name should be matched. Otherwise, it is throwing the error. Okay, so there you are. After that, you are giving the template, metadata, and labels. Labels, app name. So in the match labels, these should be matched. And after that, you are giving the container specs here. Okay, here up to this part, you are giving the deployment specs here. Now here giving the container specs. So what is the name of the container? So it is 3 apps hyphen container. So what is the image name? Here you can give the image name. So currently the image is available in my local. Okay, the image is available in my local. Therefore, I am giving the image name as 3 apps colon 1.0. So currently the image is available here. So 3 apps with the version 1.0. Therefore, I have given the same name. I have given the same image name. If you give any wrong name, it will throw the error. Next, very important, image pull policy. The name itself indicating image pull policy. For example, if the image is available in the remote repository, say Docker Hub. So then, if you want to pull the image from Docker Hub, if you want to pull the image from Docker Hub, here you should mention always. Here you should mention always. Whenever you mention always, so the image is always pulling from the repository. The image, these 3 apps colon 1.0 is always pulling from the Docker Hub repository. Okay, but when you are using the Docker Hub repository, here the image name should be very careful. The image name you need to give like this. So Vasishtha DevOps, so colon 3 apps 1.0. Actually, you know that in the Docker classes you already know about this one. So this is called as a Docker tag. Okay, so whenever you give the image name like this, then only it can recognize it. Then only it will connect to the remote repository. Then only it will connect to the remote repository with the username. If you do not specify the username, so from which user it can fetch the image. So that's why if you want to pull the image from remote repository, you need to give the image name should be like this. Okay, if you are given never, if you give never here, what happened? It won't pull the image from the remote repository. It is always checking whether the image is available in local or not. Okay, whether the image is available in the local or not, it is checking. If it is there, then deployment will be done. If it is not there, it is throwing the error. That's why here the representation of image is very important. Okay, next one. Next one, image pull policy is done. Next, ports. So here on which port this deployment should run. So currently the container port is 80. You can give the port name, any name. So you can give the any port name. So container port is 80 because the service is running on the port 80. Because I have deployed this application by using Apache 2. Therefore, Apache 2 running on the port 80. The container port is 80. So this is the way to write the deployment file. So this is the way to write the deployment file. And next, how to write the service file. So if you know how to write these deployment and service files, you can easily work with the Kubernetes. If you write how to write the deployment file and service file, you can easily work with the Kubernetes, because this is the main important part. Next one for service. So similarly, API version, so V1, and kind is service. So here the kind you have given is deployment. Here the kind is you are given as service. So because you are creating the service file now. And metadata. So here whatever the metadata you have given the deployment, the same name you need to give here. Otherwise it is throwing the error. Sorry, here not in the metadata, in the labels. In the selectors, you need to pass the same name. For metadata, the service name you can give any name, no problem. So 3 apps hyphen SVC have given. SVC means service. In the real time, shortcuts are used. You don't need to type service. You can use SVC. kubectl get service. Instead of that, you can use kubectl get SVC. That is also will work. So next, specs. So selector, you will give the application name, app name. So 3 apps. So here, this selector name in the deployment, selector name in the service should match. Otherwise, it is throwing the error. Next, ports. In the ports. So why you are writing the service? Because you want to expose this deployment. That means I want to run this image, okay, in my particular service, in my particular port. I want to run this image in particular port. Let us say 30,001. I want to run this image in this particular port 30,001. For that, you are writing the service file. Okay, so here the port, the name of the port. So here, whatever the name you are mentioned in the deployment, the same name you need to mention here. Okay, next port, the container port is 80 and node port. So on which port you want to run this image? So I want to run the image in the 30,001 port. That's why I need to give 30,001. Next protocol is TCP. Type is node port. This is very, very important. So currently I'm explaining about the node port only. That's why. So type is node port. If it is a cluster IP, so you need to provide like this cluster IP. If it is a load balancer, so you need to specify like this load balancer. The name should be very, very important. L capital, B capital. So for cluster IP, C capital, IP capital. And for node port, N capital, P capital. So like this, you can create the service file. So if you don't know how to create the service file, and moreover, remember very, very important point, this is a YAML file. Okay, YAML, it is very, very it is very, very sensitive one. That is indentation is very, very important. Indentation means the gap. Okay, so it should be start from the characters 3. For example, here you have taken like this. Okay, here you have given like this, here you have given like this, and something you have changed like this. You are wrongly created the values file. So here there is no proper indentation. Actually, indentation means the next third character, the next line should start. That is not all the lines, the related lines only. But if you don't know how to write the YAML file, just copy this. If you done any mistake here, so just copy this. Okay, so just go to the Google. You can see the YAML formatter. Okay, you can see the YAML formatter. So go to the YAML formatter here. So just copy here. Just cut this, paste here. it should give it I'm giving you can see number of options. So here you can give so format is giving like this. So here some okay, it is not allowing more than so for example I have given like this. Let us check. It sometimes it is not working. So this you can go to the YAML formatter, then you can edit this file. It will automatically give the proper correct one. Correct formatly it is given. Okay. So now I want to do the deployment with this. Okay, I'm taking this one. We'll just copy this. I'm keeping here the name. I have already placed it here. So here you can install this software called Visual Studio Code. Visual Studio Code. This is very, very friendly. Okay. If we don't know how to write the YAML files, it will show it. Okay. It will show how to write the YAML files. For example, I'm taking a sample example. So here you need to select the language. When you select a new file, it is asking to select a language. Click on here. So type YAML. So it will show the YAML language. It support all the languages. So YAML. Now, if you don't know how to write this deployment file, so just you can type Kubernetes, but here you need to install the plugin. Here you have the plugin is there, so you need to install the plugins Kubernetes. You can see n number of tools here. So here Kubernetes, just install the plugin. When you install the plugin, it is showing all the deployment files, service file, sample files. It is showing. Simply you can edit the file. So just now you can type. Okay, so here the new Kubernetes the YAML file. Kubernetes it is showing, but it is not. I think let us try this. So here you can see Kubernetes service. So see here, it is automatically showing. Now simply you can read this one. Simply you can edit this one. So the port, the target port. So you can easily edit here. So similarly, if you want to write a deployment, Kubernetes, or you can write Kubernetes deployment. So see deployment. So this is a sample deployment file. So in the original deployment file, you can see a lot of stuff. Okay, so like volume mounts, ports, and environment section, you can get the DB details here. Okay, so liveness probe, readiness probe, and interviews, they're asking these questions. You can just go through the website and just read about this. What is liveness probe? What is dimness probe? Okay, because I can't explain the theory in the demo classes. Okay, so what are the resources? Okay, so like this, you can create this file. Okay, the another beauty of this Visual Studio Code is you can use the terminal here itself. So if you see the terminal, so here you can execute the commands. Here you can execute the commands. No need to take this one, or no need to take the git bash. So in the Visual Studio Code itself, you can execute the commands. Okay. Anyway, I'm taking this. So here already I have given the name this one. I'm deleting this. Here this is a deployment file, and one more. So take the okay now. So I deployment. So this is a deployment file, same what I've explained right now. Okay, so here course red, here this is course red one. Let me create one more one. So take YAML script here. I just copying this one. This is 3 apps. Just paste here. Okay, save this. The name 3 apps. I think it is there already. It is already there. So 3 apps. The same thing I have given. So you can execute this deployment file and service file separately. Okay, you can execute the deployment file and service file separately, or you can execute by keeping them in a single file. Understand? So if you want to execute the deployment file, so then what is the command? So the command is kubectl. So kubectl create -f the file name you need to pass. So this is the command to create the pod or deployment or service, the common command. So here you are giving the some file name, right? So just use the file name. So this up to this the command is common. kubectl create -f. So we can also use one more command for creating them. kubectl apply. kubectl apply -f file name. So both commands will do the same functionality. So, but what is the difference? So kubectl command is creating a fresh files. A fresh files. It may be pod, it may be deployment, it may be service. Whereas kubectl apply means already you have the existing files there. So you are done some modifications in that file. So then you can reapply the existing files. Okay. So reapply or recreating the existing files. For this, you are using the kubectl apply, but both commands will give the same information, same output. So here I have saved this with the name 3apps.yaml. So you can create individually or combinedly. It's not a problem. Okay, in the single file, I have mentioned both deployment as well as service. Or if you want to see here, I have given separately right here. Hi deployment is there. So here only deployment file. Okay, see here is only pod file, and service. This is only service file. Okay, but I want to run individually. You can run here simply, but you need to apply 3 times. kubectl create -f hide dep yml. Okay, kubectl -f hi _pod. So no need to apply this file, because when you do the deployment, pod also automatically created. So no need to go for this one. So if you want to create one more service file, hi kubectl create -f hi underscore service. So in this way, you can do multiple times. So instead of giving multiple times, so simply you can give a single file. In the single file, you can give both deployment as well as service like this. Now here you can simply execute the command. So here kubectl, if you see the kubectl version, so it is showing the version. Now if we want to execute the command, so kubectl create -f. So what is the file name? It is 3apps.yaml. Click on enter. So see here, it is showing the deployment creation, it is showing the service creation. So to list out the deployment as well as service, the command is kubectl get all. Now see, it is showing the creation of pods. So 3 apps pods. So see, if you observe here, 2 pods are created. 2 pods are created. Why? Because in the replicas, you mentioned as 2. That's why 2 pods are created. And here, if you see the service, so service is node pod, and this service is available in the 30,001. Okay, and next deployment. If you see the deployment, so there are 2 deployments are there. So 2 by 2 it is showing, because 2 replicas are there. If you delete one pod, automatically one pod will come into the picture. That is the nature of Kubernetes. Now, how to access the application? Just go to the web browser. So since I'm accessing the application with the help of localhost only, right? Because it is a node port. So localhost, what is the port? It is 30,001. That is, I have already given in the service file. That's why 30,001. So colon, I have given some 3 files in that. 3 files in that image. So hi.html, and next I think hello.html. No, it is not there. So welcome.html. Yeah, welcome.html is there. Okay, so hi.html I have given. One more, I have given 3 images, whatever it may be. So just whatever the images you have given, the same here you can able to access by using the node port. Okay, by using node port, you can be able to access the applications. I think, let me check what are the images I have given there. The Docker. Already here I have mentioned it. So course HTML, hi HTML, welcome HTML. So 3 images I have given. So let us access this course HTML. So course HTML is running, hi HTML is running, and welcome HTML is running. So 3 apps are running, right? So if you want to change the port, just change the number and redeploy again. Change the port here and again redeploy. Okay, it is working on the different. So in this way, we are working with the node port. So any doubts in the node port? So this is the process I have made for creating the node port. So first, create the 3 HTML files. So course.html, html, welcome.html with some content. So place the 3 files in the volume folder. Okay, so create a Docker file and create image with the name 3 apps colon 1.0. This is the image. So and this is a Docker file for creating the image, and create a deployment and service. So this is a deployment file and this is a service file. Okay, and next kubectl get all to see all list of resources and access the service with the port. So that is be done right now. And one more example I'll tell you. So how to pull the image from the repo. So if you go to the Docker Hub repository, my Docker Hub repository, So in my Docker Hub repository, currently, I think two or three images will be there. Yeah, 3 images is there. So course -orange, course -red, high course. So 3 images are there. So so if you want to take the image from this repo, so just copy this persistent DevOps /course -orange. So from this you can access this image. Okay. So for that, what I need to do? So here I'm closing this session. For that, course red is there, for example. So here I'm giving the course red. The same thing, there is no change. The same YAML file what I have given, but the name is changed. The metadata name I have changed here, and the match label, that is app name is changed here. Okay, whatever the name here, you need to pass here. And I have changed the names here. You can give any names, but very important, image name should be like this. Image name should be like this. And here you need to mention always. Here you need to mention always. Okay, always you need to mention. Next, so port is nothing but same as it is. So now I want to run this port on the 341s. On this port, I want to run the service course -red. Now just apply this one again. Okay, so kubectl. Okay, here I'll apply. So kubectl. But before that, you need to move into the folder. Otherwise, it won't understand where it is. So the folder is available on the desktop and Kubernetes. In the folder, it is there. In the desktop directory. So this is the Kubernetes folder. So cd Kubernetes. So in this folder, I have these files. Now I want to apply this course -red YAML. So kubectl. You can use create or apply. Anything is working. Okay. kubectl create is used for creating the fresh files. Apply is used to creating the existing files. You do the modifications and you can apply the changes. So create -f, but apply is not working on the fresh files. Remember that. So course -red YAML. Click on enter. Now see deployment is created and service is created. Now if you want to see the deployment and service, kubectl get all. So it is 0/2. Means what it is the message. You can see the status here. What is the meaning of status? Container creating. That means it is pulling the image from the repo. It is taking some 1 minute, sometime like that. Okay, depending on the internet also. So if you check again, so see it is running. So the image is taken. I already told you at any cost you need to see the 0 restarts. Okay, there should not be any restart. Okay, you need to mention, you need to see always running status. The pod should run always. Okay, so the service is here, course service. Here it is node port, and it is accessible on the port that is given. I have given the 341s. So if you want to access this, so you can access this in the local also. So curl localhost :341s/red.html. See, so this is the content of the image, right? You know that this content already. Now, if you want to access the same application on the browser, you can see the actual output. So in this way, we can work with the node port. So if you want to do for orange, okay, I have 2 images right in the repo. If you want to go for orange, just change the name here. But here need to change the name, otherwise it is showing the error. So because already course deployment name is already there, so I'm changing the name to course deployment 1. Okay, here also service should be name changing to service 1. Here in place of red, I'm giving the color as orange. Okay, I want to run the service in another port, say 342. Okay, now I want to apply this file again. So what is the command? kubectl apply. I'm doing the apply now because I have done the change in the existing file, right? That's why I'm doing apply. So apply. So what is the file name? It is course-red.yaml. So deployment is created, service is created. So the name is deployment one. Service name is service one. If you don't change the names, it is throwing the error because already the name is exist previously. Therefore, kubectl get all. So now it is still container creating status. Once it is container created, then you can see one by one. Currently it is 0 by 1. So here pod is 0 by 1. So deployment is 0 by 1. Okay, service is available. Service is available node port in the port is 342. Now if you check the kubectl again, so now the pod is running now. Now if you see the local host on the port is 342 followed by orange.html. This is the context path I have given in the image itself. That's why I remember this. Orange. So let us check the image. What I have given.
Red and
Sorry. Course-orange. Course-orange. So let me change the port. It is unchanged. Service is configured. Service is changed, but deployment is unchanged. Okay, kubectl get all. Now what is the port? 30,050 I have given. Let's try to access this. See, it is working. Because that port may be allocated for some other thing. Like this. No, this is not working. It should also work. Right? No, it is stopping. But actually both should run, but somehow I think only one application is running and the node port. Okay. So that's why we need to go for load balancer. If you're going for load balancer, you can run multiple applications. Okay. So this is about node port examples and everything. Okay. So shall I continue with the ingress load balancer, or shall I stop here
Tomorrow, sir.
tomorrow? Okay. Okay. So tomorrow I'll continue with the load balancer. That is very, very important because in the real time, mostly the Nginx ingress load balancer only used. That's why you need to more concentrate on the load balancer. So till now, if you have any doubts, you can ask me. Otherwise, you can leave the session.